So in this case, we are going to have a concept of the proving of arithmetic and also the geometric series, which is important in your syllabus. Sometimes they can give you a question to prove the arithmetic series, what is the sum of terms, and also for the geometric. So without wasting time, guys, we have got the difference between the series and the sequence that we had. So this is arithmetic series. So we just need to understand the basics. As we had a sequence before, remember a sequence, you're just having your terms separated, T1, T2, T3, and so on. That was a consideration of a sequence. But if you're considering a series, we are now taking these terms, combining them together. That is adding these, a series of, that is adding these. So we are going to consider, let's say, Sn given in terms of the terms T1, T2, T3, and so on. But now they are being added together. They are being added together. That's T3 plus and so on and so on. The terms that you had in a sequence, now they're being combined together. As they are being combined, these terms, we do not know what is going to be the last term, but these terms they're going to be and so on and so on, up to the last term, which you can call that Tn, which represents the last term, as I explained before, that Tn represents the last term, which is given as A plus n minus 1 times y times d. This is your Tn. Remember that. You're supposed to remember what we had from a sequence. So it follows that the sum of terms that we are talking about, which is given as Sn, adding these terms together, was going to be concluded with a formula which states that Sn is equal to, that's n over 2 into 2a plus n minus 1 into d. This is the formula that you are also given in your formula sheet. Or we can have this as Sn. This one we are not given, but you're supposed to know this. It's also part of your syllabus, where we are going to use a plus l, n over 2 into a plus l, as we had before. A being the first term, everything there is not going to change. A is still representing your first term. From the sequence, n being the number of terms that you're given. That's D. Remember, this is arithmetic, so you're talking of the common difference. So this is your common difference. We talked about this. If it is of this nature, L represents the last term. So L is your last term, which is given from the formula of Tn there. So these are the formulas that we are actually going to use when working with an arithmetic series. It's now the sum of terms. On a sequence, we're just working with finding of the nth term. But here we're not talking of questions using of the formula, no. We are talking of proving that it can truly be used for these formulas. That is what we need to prove. How can we use this formula? It will be on another part. Now we need to prove this. All right, so let's start with the first formula. That is Sn, still on an arithmetic. All right, so we're on the proof. I said these terms are given. Remember, this is from an arithmetic sequence. The terms as they were given on a sequence is T1, T2, T3, and so on, and so on, and so on, up to the last term as they were from a sequence. Remember, it was from a sequence. Under an arithmetic, we understand A represents the first term, T2 the second term, which we can write as, maybe we just want to write this in short, where there's a common difference. So this is going to be A plus D. It's a sequence that you're going to have A plus 2D and so on and so. This is the basic way of expressing an arithmetic sequence. All right, where is this actually taken from? Remember, Tn is equal to A plus n minus 1 times D. This is how you write it. So if it is the first term, you're talking about T1. You're going to substitute 1 here. That's 1 minus 1, which is a 0. So 0 times D. This cancels. You remain with A. So this is your A. So if you're talking about T2, it simply means if this is 2, this here is going to be a 2. So meaning to say at the end, we are going to have A plus 2 minus 1. That's 1. So it's going to be 1D, which is simply A plus what? A plus D. So you're going to notice it is going to be a continuation and so on. If this is T3, this is going to be 3. 3 minus 1, which is 2. So it's going to be A plus 2D. This is the part that we are having here. A plus D. It's something that we are taking from the terms of our Tn. So under a series now of the same terms where I said Sn is given by the terms T1 plus T2 plus T3 plus and so on up to the last term, which is Tn. The same Tn is written this way. Remember, we are writing this in terms of this. So that Tn is going to be written as A plus n minus 1 times D. These are the terms that are given on a sequence. Take note, guys. So the last term that we're going to add at the end is our Tn, which is given like this. All right? Now they are forming a series. We added them together. Let us substitute as they are. The T1, remember it is A plus our T2. It is going to be A plus D and so on. So that's A plus D plus our T3, which is A plus 2D. So it was going to be a continuation, guys. A plus 3D, A plus 4D, and so on and so on. A plus 5D, A plus 6D, and so on. We're going to add these terms and so on up to the last term, which is called Tn. And that Tn is given by this formula, the one that we had before as we are working with our normal arithmetic sequence. That's A. Let us just give it as it is, which is A plus n minus 1 times D. This is representing our last term as the sum of terms. So this is what you're going to do. Remember, we need to prove. So we wrote this in terms of A and D, and also we have N there. Less questions, guys. It's a follow-up that you just need to follow up the idea of what is happening. Yes, somehow we just need to know the simplification, but the stages just need to follow up as they are. In this case, let's say we reverse our equation. Same Sn that we are given. But this time, we are going to have it as a reverse. All right, so let us reverse the series. We are going to reverse the series. How is this possible? The first term. So as I had here, if you are to consider the terms that I'm having, okay, here I'm having 3 terms. Here I'm having just 1 term. So I'm going to also have 3 terms. From the last term, going backwards. We are now going backwards. Okay, before this last term, what was the term that you had before? What was the term that you had before? All right, so this is what we are having. So that is reversing. So Sn is equal to, all right, let me just have it here. So that's Sn is equal to, start with the last term. So that's A plus n minus 1 times D. This is our last term. Plus, we need a term which was there before here. Because you're saying there are so many terms, but what was the term before this last term? So this was an order which was being maintained. The n minus 1 is the last part. So meaning say before, another one, n minus 4, n minus 5. These were the terms that we saw. The effect there is going to be on this n minus. Everything is just going to remain as it is, but it's going to be n minus 2. So that's n minus 2 into d like this. All right. So this will be the second from last. Like we have another term also. So you're just going to subtract 1. This is minus 2. So just subtract 1. So it's minus 2. We also subtract 1 here. So it will be minus 3. So that is going to be plus, that's a into what? N minus 3 times d like this. So these are the three terms, just like what we. So here we started with the term from the last, going back, but we just need three terms so that it will correspond 4. Then you must write 4. If you use 2, then just work with 2. Here I used 3. So I'm just going to work with 3. Then I know that as I am reversing this, going back, going back, going back, the first term here is going to be my last term. Remember, we are reversing from the last term to the first term. So the one that we had as our first term, it is going to be our last term. So as we add and so on and so on and so on, the last term that we are going to have on reversing was our first term from equation 1. So that is the idea there. So this is reverse the series. After reversing the series, what are we going to do? We are going to add, because we have, okay, let me write this before we talk about the issue of addition. It is going to be equation 2 like this. We are proving the formula that we are proving. If we take note on this formula, it's Sn is equal. Look at the formula there. The one of the first equation, then the one that we have on the second equation. These are two of them. We are going to combine these two, add the two. So let us combine. That is, we are going to add equation 1 to equation 2, or just add equation 1 and equation 2. Meaning to say, as we add, remember, so we've got equation 1, equation 2. So we add starting from the left side of the equation. We are supposed to add there. So this is same as got 1, and this is 1. So as we add, guys, we're simply adding 1 plus 1 on that Sn. These are like terms. So it's Sn plus Sn. 1 plus 1. So that's 2. So this is going to give us 2Sn, which is equal to, remember, we added the left-hand side of the two equations, equation 1 and equation 2. We move on to the right-hand side, also adding. That's why I was talking about this issue of having terms which correspond. If you have got 3 terms, you know that you're going to work with those 3 terms corresponding. A here corresponds to this part here. These two, they correspond. So we're going to add those two. Those are the terms that are corresponding together. The A plus this part here. Remember, you're adding. So we're going to add A plus n minus 1 times d. This is the part that we are adding. So as you can see, guys, A is not part of this bracket. So you can even add this to n minus 1 times d. We can just leave it like this. Yeah, 2a, something like that. So you can see it's here, 2a plus n minus 1 times d. We can see that we are in the right direction. We have that sort in our equation, on the formula. So we added these two, all right? So let us write what we got. So this one gave us 2a. Okay, just gonna write this. That's 2a plus n minus 1 times d. Okay, n minus 1 times d like this. By adding the first ones, we move on to the second one, and so on and so on. So we need to do this throughout and see. All right, so let's move on to the second part. We need to add the second part. Here we are. This is the part of a plus d, this one, added to this part of this one that we have here. So we need to add here. Okay, those are the corresponding first term, second. We are adding. All right, so I'm just going to try to add here. So this is a plus d. So that's a plus d added to this one, which is plus a plus n minus 2 times d. How can we simplify this? We can see that we've got like terms, which is the part of a and a. This is not part of our bracket, so you can even add 1a plus 1a. We are back to our like terms. So this is going to give us 2a. All right, then the part of d, there is this d, then there's also this d that we are having here. So these ones, they are common. So what we're going to do there is to factor out the d, which is common. I want you to see what was going to happen here if we factor out this d, because this d is common. So you're going to have something like this. Plus, okay, we know that when we factor out, we are going to have what? A bracket. But the d, I'm not going to write it here because we know, guys, the sequence is, okay, the way that we write the d is this d. Yeah, I'm going to write it here. I want you to see what was going to happen because it's common. you are going to remain with what? If you factor out d here, you remove it. D divided by d, that was going to give you a 1. What's n minus 2? What were you going to remain with? You're going to remain with the plus n minus 2. You factored out d here, you remain with the 1. You factored out d here, you remain with what? N minus 2, which can be simplified. Further inside of the bracket. We can simplify. All right, let's take the n, it's positive. Then we can simplify this one, it's 1 minus 2. 1 minus 2, which is minus 1 times d like this, which is outside. So as we can see, guys, we're having the same bracket as this one. So this was the other terms you're going to have same part. This was going to be 2a plus n minus 1 times d. Just like what we got here from the first one. You can see the first one, second one is the same. We move on to the one that are corresponding on the other part here. We're going to have the same answer, all right? We're going to have the same answers there. If you are to consider the third part that is corresponding, a plus 2d here, and this other part that is, which is a into n minus 3 times d. We're going to have the same answers. Okay, let's just prove for the sake of revision, but you're going to see that it was going to be the same. Remember, you're adding, so you're going to take this a plus 2d. So that's a plus 2d. You add to this one, so it's plus a into n minus 3 times d. Just like the previous case, we can not for the like terms. If they are like terms, you have to consider your like terms. All right, so this is a plus, there's supposed to be a plus here. We're supposed to have a plus here. There's a plus here, a plus. So there is a plus here. So take note here. We have a plus. So it was supposed to be a plus 2d. Then we add a plus here. Can we correct that? So meaning to say, considering your like terms, just like the previous case, we've got a here. We've got a here. So this was going to give us 2a. All right. Then the part of d, just like the previous case, it is common. There is a d here. There is also a d here. So if we factor out this d, which is common, it's there. So let's factor out d here to give you a 2. All right, you divide this to this. You do the same thing, this d and this d cancels, meaning to say you're going to remain with n minus 3. So that's plus n minus 3. So we simplify what is inside the n, then 2 minus 3, that's minus 1 times d. So as you can see, guys, same answer. You're going to have the same thing throughout. All right, it's plus n minus 1 times d. So this is what you're going to have if you add these corresponding terms for the third terms. The same thing on these terms which are on the last term. So remember, this was supposed to be a continuous addition. As we add, and so on, and so on, and so on, up to the last term, which we are considering as the last terms. You're supposed to have the same answer also to a into that. All right, so let's see, guys, what is it that we have? Remember, from this sequence that we are given the last terms from the first equation is this, and the last term here is a. If you were to add, guys, you can see that only part that we're going to add was the a and the a. So a plus a was going to give us 2a. The rest was going to remain as it is, as n minus 1 times d, which is the same as what we had before. Which is the same as what we had. So under an exam condition, this is what I need you to know, because here we are just having the basics of our introduction for you to understand what is happening in this type of a series. But as you are to revise, as you are to work with your exam, you know that you're proving an arithmetic series. Just you have your Sn, this equation, you have your equation 2 by reversing that equation. Then the moment you add, know that whatever this first part is the same, just repeat it throughout. You just have to repeat those terms throughout. You're not supposed to waste time under exam years just for you to know where it was taken from. So you do not need to prove all that addition that I was doing. Just take one, you see that you saw that it's going to be the same. All right, so this is it, guys. So 2Sn is equal to what? Basing on our knowledge of the sequence or addition, let's say there are a number of terms that you are adding, 3 plus 3 plus 3, a number of times. If you add 4 times, it is 3 times 4. If you add these ones 3 times, it's 3 times 3. If you add 2 times, is 3 times 2. What if you add any times? Because we do not know how many times are we adding up to the last term. So if you add 3 any times, it means 3 times n. Whatever that you have times n. Times the number of times that you are adding. So meaning to say, we are going to have 2 like this, the whole of this expression that we are given, this one, multiplied by n, the number of times that it's adding as we are adding the same bracket, which is the same. So you're going to multiply by n, which is the number of times. So you multiply any times. Just like I was explaining to say, if you are adding 3 5 times, 3 times 5. If you add 3 4 times, 3 times 4. So if you add 3 any times, it's 3 times n. The same part that we are adding these. How many times? We do not know. So we are going to use n there to show that it was a repetition that was happening. We need to find Sn. So what can we simply do? Divide by 2. Can see both sides of our equation. So that's it. So therefore, our Sn can be given. Remember, multiplication is only allowed to carry the denominator, only one. So it is either I can write it as A over C times a B, or I can write this as A times B over C. Multiplication is only one. It is not B over C. The moment you write it like this, it's wrong because C times C is C squared. So it's only one part which carries the denominator. That's for multiplication. Addition and subtraction is where you separate every term by the denominator. So meaning to say, if this is a multiplication, it allows us to separate n and 2. So we are going to have that as n over 2 into what? The remaining part, this one, without this is just like A over C times B. So you just multiply to the remaining part as it is, which is 2A plus n minus 1 times what? Times D. So this is our sum of terms of an arithmetic sequence as we are given from our formula sheet. We have this formula, but they can ask you to prove it. There are questions like that where you're asked to prove this. You're supposed to know this. Or the layout that was there before, it was supposed to be written, your addition. There's no one part here, guys. Everything remains as it is. Then you just know, okay, addition, I multiply by n to show that I'm adding this a number of times that we do not know. Then from there, divide by 2. You have your Sn. All right. But as we saw from these formulas, it is not only this is not the only formula that we actually have. So I'm just gonna have it. All right. Let me just have it this way so that we can see what is happening here. If we cross-check properly, we can see that this is not the only formula. I listed 2 formulas here to represent Sn of the same arithmetic series. If we are to use the formula, the second formula, what is it that we are supposed to have and how are we supposed to present? All right, just like what we had before, but this time we are going to have, all right, so we need another part. So this is, all right, let me just have it here as this one. So this is another way. So remember your T1 is given, your sequence is given as T1, T2, and so on. It was written in terms of n up to the last term, which is Tn. But this time we are going to take our last term, which is L. We do know that L is the last term. It represents Tn. That's our Tn, which is the A plus n minus 1 times D. That's our Tn, the L. So instead, we can have these as Sn, the sum of terms. We're going to have T1 plus T2 plus T3 plus and so on and so on. Up to the last term, which is L. Remember, we want to have our answer with what? With L. So in place of Tn, we are going to use L, which represents the last term. Okay? So if these terms were given in terms of L as your last term, having the sequence, having this series that we are having, T1 does not change as we had before. So we're going to substitute T1. Remember, it's A plus T2. That's A plus D plus T3, which is A plus 2D. Remember, we're under an arithmetic. A plus 2D, like this, to the last term, which is L. So just going to write it as L. L represents the last term. This is what we're going to have in terms of L. This is what you're going to have. So let's say this is our equation one. Remember, we have to reverse our equation. So if we reverse this equation, it means we are starting with the last term. Let's say the last term is 20. Let's say the last term is 20. How are we going to find the term that is before that last term? What was the term before? It means that was 20 minus 1. You sub 2. 19 minus 1, which is 18, and so on. You're just subtracting 1 to be having. Remember, you were adding these terms, a plus this n minus 1 there. You can see that there's a chain of a common difference. Now we have to get that back. So we subtract. If there's a difference of 1, we subtract a 1. A difference of 2, we subtract a 2. So what are we having in this case as our difference? A difference of d. So if the last term is L, the term before will be L minus d, L minus 2, and so on. We are now having a reversing. If there's a difference of 1, as you hear the numbers, 20, 20 minus 1, 20. If there's a difference of 2, 20 minus 2, the other one is 18 minus 2, you have that difference. So that is the reversing part that you're going to have. So as we reverse, guys, our Sn from the last term, which is L, followed by what? We are going to subtract the difference. We're adding the difference before. This time we subtract. So it's L minus D plus L. We subtract the difference, L minus 2D, and so on. So this will be minus 2D plus, and so on, and so on, and so on. We are reversing from the last term going where? That we are going to have. As we subtract these terms, we do not know whatever that we are going to subtract. We are going to end with A at the end, which was our first term. And it becomes our last term of the sequence of the series now. So this is what we have as our equation 2. So as you can see, it's just a repetition of what we had before. We add the two, equation 1 and equation 2. So we're going to add these two. So as we add the left-hand side on its own, that's 1 plus 1, Sn plus Sn. This is going to be 2. Sn is equal to, you move on to the right-hand side, you do the same thing, corresponding terms. The first added to the first. Equation 1 plus equation 2. So if we add, what are we going to have? A plus L, that's A plus L. This is not going to change. So it is just going to be A plus L like that. You move on to the other part. Remember, you are adding plus, you add what is corresponding again, the next terms. There is A plus D. This is L minus D. So if you combine these two, what are we going to have at the end? A plus D plus L minus D. We can see that the D and the D will cancel. We remain with A plus L, which is the same part, A plus L. So it was going to be a repetition, guys, throughout, as we saw from the previous proof that we had. Meaning to say, as we were to work with the terms which are corresponding here, the A plus 2D, the L minus 2D, same thing. We're going to have A plus L. And so on, and so on, and so on, up to the last term. So your last term, that is just one and the same. Remember, under addition, A plus B is same as B plus A, is just one and the same. So you're allowed to even write as A plus L. So if you take note, you see that what you had from the first bracket is the same throughout, just like what we had in the previous case. The moment you have the A plus L, guys, under exam condition, know that all these ones will be a repetition. So just repeat them as they are. So from there, we can combine just like the previous case. If A plus L is being added a number of times, the same thing being added a number of times, for how many times? For any times. So it is going to be n into A plus L. You multiply by n. The number of times that we are going to add. We do not know how many times, so we're going to use n. So you need Sn, simply divide by 2. We are done. So n can be written, like I said, you can separate this and write it as n over 2. So you can have it as n over 2 into these questions can be given as. So you do not know, what are you going to be asked to prove? Are they going to ask you to prove this? Are they going to ask you to prove this one, which is the first one? You must know both. You must know how to prove both. That's how these questions can be given under an arithmetic. So it is something that you are also going to consider even if you are working with a geometric. So for a geometric series, so we just take it from the sequence as we had our sequence before. Remember your sequence, the Tn was given AR to the exponent of n minus 1. This is what we had. Under a series, we're now talking of the second term, last term. It was going to give us Sn, which is given as A into R to the exponent of n. This is your formula for the sum of terms of this series. In this case, our R is supposed to be greater than 1. It's supposed to be bigger than 1 if R is bigger than 1. So if they ask you to prove for this one, the other one we're going to see, guys, as we are doing question papers, we're going to see how they ask the questions. Let us just work with this one. You're already given the formula, but you need to prove this formula. How to obtain, just like what we had the previous case. If we are to consider this, let us just figure out how terms are given under a geometric sequence on its own. What from our sequence before? Remember, it was T1 followed by T2, T3. The first term is A, second term is AR, the second term is AR squared, AR. It is a continuation, that is, of the terms. It's a continuation from this AR to the exponent of n minus 1. To say if it is the third term, it's AR to the exponent, the third, in place of n, you substitute 3 minus 1. So that will be AR squared. That is how you're simply getting this, AR squared. The fourth term, you substitute 4 minus 1, which is going to give us a 3, and so on and so on. So these terms now, they are being added. All right, let's quickly rush to the proof. They are being added this time. The T1 that we had before, remember, it was T1 plus T2 plus T3 plus and so on, up to the last term being added. Let's substitute these terms and see how they can be presented. This is A plus the next one, that's AR plus so on the third term, AR squared, the fourth term, AR to the exponent of 3, AR to the exponent of 4, and so on and so on, up to the last term, which is your Tn, which is given as AR to the exponent of n minus 1. These terms were being taken like this throughout. We're being taken like that throughout. So I want us to note something here on this equation. It is going to be different the way that you prove. This time we are going to multiply by R each term. All right, so this is how we are going to prove it. This one, you multiply by R, which is the common ratio, each term. So that is the difference on how to prove geometric. This time you multiply by R, meaning to say the left-hand side, we're going to multiply by R. Here, we're going to multiply by R each and every term, So let's multiply this. So it is going to be R times Sn, each and every term, guys. Every part that you are seeing. All right. So meaning to say, if you multiply this by R, it is going to be AR. You move on to the second term. Remember, you're multiplying by R. So it's AR like this times R. So that's R times R, which is going to be R squared. So that's plus AR squared plus, definitely, you multiply this by R, it was going to increase to the up to the last term. Okay, let's figure out what was going to happen. What was going to happen on the last term? It is AR to the exponent of n minus 1. You multiply by what? By R there, which is to the exponent of 1. Remember, R is just same as to the exponent of 1. We know that if you're multiplying same bases, we add the exponents. So it is going to, we are going to add n minus 1 plus 1, n minus 1 plus this one. So what are we going to have at the end? It was going to be R to the exponent minus 1 plus 1. That's a 0 there. So that's n plus 0, which is what? Which is n. So the last term was going to be AR to the exponent of n. If we multiply each and every term by what? If we multiply each and every term by R. So we have two equations here. So let us just write it this way so that we do not confuse each other. This is equation 1. This is equation 2. So in actual sense, to have this equation, we multiply equation 1 by what? By R. Equation 1 by R. Each term from equation 1. So there are two equations, equation 1, equation 2. So we can see that equation 2 is the adjusted one and having the bigger exponents compared to equation 1. So remember, I talked about there's a question that we did when we had two equations. I think it was something like AR to the exponent of 7 is equal to 9. AR to the exponent of 9 is equal to 25, where we divide equation 2 divided by equation 1, equation 2 over equation 1. We work with where we have the bigger exponents, the bigger values. So you can see that the bigger values are from the equation 2, 2, 3, and so on. These are bigger values. So we are going to subtract. If we divide, we divide. But in this case, it's not on the division. It's on the subtraction that is going to happen. So we're going to subtract equation 1 from equation 2. All right. So we are going to subtract that's equation 1 from equation 2. Simply meaning to say that's 1 minus 2. That's 2 minus 1. So we are saying equation 1 from equation 2. So it's equation 2 minus equation 1. That is what I'm simply trying to say here. So equation 2, this is our equation 2. It must subtract equation 1. So let's start with the left-hand side. So we're going to subtract these two on the left-hand side. So that was going to be RSN minus SN. There's SN there. So we subtract is equal to, we are subtracting, guys, corresponding terms, but it is equation 2 to equation 1. So you have to subtract corresponding terms. So it's AR minus A. So that is what we were going to have there. We are subtracting. So it was going to be AR minus A as we are subtracting these terms. All right. So if you consider this part, yes, it's first term and first term. You subtract, you say, okay, there's nothing that is going to work out. You move on to this one, there's nothing that's going to work out. This one, there's nothing that is going to work out. So what can we do? Because we are supposed to obtain something familiar, but we can see that it's not happening, just like what we had under an arithmetic. Looking closely, we'll see that these terms are not corresponding first term to first term. No, they are not corresponding that way. But they are corresponding second. This one, AR, corresponds with AR like this. So that's how you subtract. So this one and this one was going to cancel because they are the same. So you see that the AR squared, this one, and the AR squared, this one, they're the same. So they were going to cancel. There was an AR cubed, which was on this first term here. There was supposed to be an AR cubed. I want you to take note what was happening here. There was supposed to be an AR cubed, which was supposed to cancel this one. So this one was going to be automatically, this one was going to cancel even though it's not there, but know that there's a term there. Remember the order? AR squared, AR cubed to the exponent of 4, 5, 6, and so on and so on. So these two are going to cancel. Meaning to say, if we check properly, it's second term versus first. Meaning to say, the first sequence, this one, I want us to consider the first series. It is ahead of this one. So when it ends here, I want you to see here, guys, the most important part is on the ending part here, where it is ending here. The end part here of AR to the exponent of n minus 1, it was going to correspond with a term also before here. Remember this sequence, the series here, the first one is leading. This one is behind. So behind, before this AR to the exponent of n, guys, there was something which was there before, which was AR to the exponent of n minus 1. That is what you need to know before we reached to this one. There was AR to the exponent of n minus 1. So it will cancel also minus equation 1, equation 2 minus equation 1, equation 2 minus equation 1, equation 2 minus equation 1. So what is going to subtract? Here we are done. We are no longer having anything here at the end. So it is going to be AR to the exponent of n minus what? What are we subtracting? There's nothing. So it is going to subtract this one at the end. So it is going to be equation to exponent of n minus a, this one, minus this a. Remember, there's a that we left. So we are just subtracting the remaining parts We remained with a from the first one. It did not cancel this one, never canceled. Here, this one never canceled, this ar to the exponent of n. So it is going to be equation 2 minus equation 1. Equation 2 minus equation 1. So this is where we are. We are almost there. It was just something else. So like I said, a proof is a follow-up. Just try to follow up, guys. Just try to follow up. This is what you're going to have, something like this. As you can see here, there's something common from both equations. From the left-hand side and also the right-hand side. The left-hand side, Sn is common. So we can factor out the Sn. So Sn, if we factor out this, we are going to remain with r here, minus Sn divided by Sn. You can see that on the right-hand side, a is common. So we can factor out the a. We remain with what? R to the exponent of n minus a, and a here is going to cancel. So you remain with minus 1. Remember, we need to find Sn. The formula is for Sn. And this is a product. So what can we do? Simply divide by the bracket of r minus 1 both sides. So this is going to cancel. So therefore, we have the sum as Sn is equal to a into r to the exponent of n minus 1 over r minus 1. As we do understand from the fractions that the denominator cannot be equal to 0. So this is a condition that denominator cannot be equal. So r cannot be equal to 1. And also we cannot have negative values representing some like the r there, unless we are talking of sum to infinity. So for this formula, we are going to use it where r is greater than 1. All right? So that is the use of this formula. Yes, they can have this. It's just going to be a repeat. 1 minus r to the exponent of n over 1 minus r, like that, is less than 1. It is a condition where r is what? Where r is less than 1. It's just a matter of a question, guys. What are you given? So like I said, guys, as we are going to do question papers, we are going to see how these questions are being given. But as for the proof and arithmetic series, is it for a geometric series? Expect a question on the proof. So you need to have taken the terms as they were before as just a normal sequence. AR squared in that manner and so on. You multiply by r this time. The first equation, you multiply every term by r from the left-hand side to the right-hand side. Then you subtract equation 1 from equation 2, meaning to say equation 2 minus equation 1. By subtracting, be careful because the terms are not in an orderly manner. The way they cancel, they are canceling in another manner. The second corresponding to the first, the third, and the second. So understand that the other one is ahead, the other one is behind. So that these adjustments where you cancel something that is not given, that you cannot see, but having that in mind, you must know that there's something that is there, which is ar to the exponent of what? Of 3. Cancel those. You remain with the part that cannot cancel, then subtract equation by the bracket throughout. You're done. So these are the questions that you must expect in your syllabus. We are going to have as much questions so that we can see our typical exam questions, like how do they actually even ask these questions. You just need to work as much as you can.